Okay, so we have this question right here. It says the student inflates a balloon. She uses a peg to keep the balloon closed. She then attaches a straw to the balloon using sticky tape. She passes a string through the straw and pulls the string tight as shown. The student removes the peg. Air leaves. The velocity of the balloon increases from 0 to max. Explain how Newton's third law of motion applied to the motion of the balloon during this time. Okay, so it's very simple question. So what is the first step? The first step that I always say is think simple, write simple. Okay, think simple, write simple. Okay, so then the mark scheme or basically the examiner, if you can see that they never write too complicated stuff, right? They ask you for simple explanation, you give them simple and logical explanation in a structured way. Okay, that's the 3 steps you have to follow: simple, structured way, and it should explain the situation properly. Okay, now when the first step out of the way, so the second step is to understand what is actually happening when you remove the peg. Okay, when you have removed the peg, what happens? The balloon will release gas. Okay, so you have this balloon, right? It has a forward and a backwards direction. Okay, so when the peg is removed, the balloon will release its gas, and then when it releases gas, it provides a force to the air molecules, right? Or you can just say air. And you know the Newton's third law, okay, which is every action has equal and opposite reaction. Okay, so if we follow the statement, that means that if the peg is removed, balloon releases its gas and provides a force to the air. Air in return will provide the force back to the balloon, right? So this is what actually Newton's third law says, right? Air will in return provide an opposite force, in other words, forward force to the balloon. So we just have to mention the first two things. Let's write it down so that we don't forget it. So what happens when the peg is removed? Okay, the balloon releases gas, and then it actually the balloon releases gas and it provides the force to the air. And we also have to mention, like, it's better to mention the direction where the force is being provided. So he is providing the force backwards. He, in a sense, balloon, okay, backward force, backward force. Okay, so due to Newton's third law, air in return will provide the balloon an opposite double O balloon and opposite force, okay, which is our forward force. So we have mentioned these two things. Now let's go to the next step. Okay, what is the next step? Next step is when all of this when all of these things happen, it receives the forward force and it starts moving, right? From this point, the velocity of the balloon increases from 0 to maximum, right? So we have to explain this statement: velocity from 0 to max. What is happening between this thing? Okay, so it receives the forward force. Now you're just okay, I have to explain one more thing, that you're not just bounded to explain this question to only with Newton's third law. You can explain it with anything else. right? It did not say that only explain me Newton's third law, right? It's not possible, because if you want to write 6 marks, right, Newton's third law doesn't say that much, so you can write 6 marks. You need to have other things included so that you can get this whole 6 marks. Okay, so let's get back to our step. So velocity goes from 0 to max. So when it receives the forward force, acceleration will increase as well, right? And how? Due to Newton's second law. Okay, which basically says that your net force is equal to the mass times the mass is the product of mass times acceleration. Okay, so if your net force, which is actually your forward force, is increasing, so your acceleration will increase as well, right? It will cause acceleration. So now the velocity, or you can say speed, goes from 0 to max. So while it's going from 0 to max, okay, the force will change. Okay, so it won't be like you have a fixed force. It's like you're increasing slowly, right? And when the balloon is like actually going forward, you can just say that when it's going actually forward, the forces, uh, the best way to explain is that the resistive forces, there will be a time when the resistive forces will be equal to the forward forces. Okay, how so? Because number one, they never mention that air resistance is negligible. So you have to mention about the air resistance or the resistive forces. So when the balloon is going forward, it will have challenges with the resistive forces, right? Not at the start, but later on when it reaches to the max velocity, right? And what do we mean by max velocity? It means that our net force is becoming zero, which means that our forward force is being equal to the resistive force. Now you won't see balloon going forever and ever, just flying everywhere. There will be a time when the balloon will come down as well, right? So it goes to this thing where the net force becomes zero, and when that happens, the speed doesn't increase anymore. Okay, by the Newton's third law, the speed never increases anymore. And Newton's third law is not that complicated. It's a very simple thing. It's about inertia. If the object is at stationary or it's at zero, it will stay at zero. If it's moving, it will constantly move unless there is any external force. In this case, we have resistive external force, so it later on will come down. But we only have to explain through 0 to max and not max to 0. So just explain to 0 to max about all of this thing. So I'm gonna write it out so that you understand the step by step what I'm doing. Okay, so the after we receive this forward force, it will be greater than resistive force. That's why it will be going forward. Okay, so the forward force is greater than the resistive force, right? So due to Newton's second law, the resultant force will cause acceleration. The resultant force causes acceleration. Okay, now we go from 0 to max, right? So the speed is increasing, right? As speed is increasing, right, the force is still changing, means the balloon will still receive challenges against resistive force, right? The force is still changing until it reaches to a point, until it reaches to a point where the resistive force will be equal to forward force, right? And this is what Newton's first law comes, right? Newton's, now you can just write semicolon and say Newton's first law comes into action where if the net force is 0, then the balloon will not accelerate anymore. Okay, so it will be actually be equal to, in a sense, 0. Okay, at max speed. Okay, so this is all of the stuff you have to actually explain. You have to first explain the point when the student removes the pegs and air leaves the balloon, or gas leaves the balloon. And the second thing you have to explain is the velocity of the balloon increases from 0 to max, right? So he mentions two statements. Now think of the examiner as he's super dumb. So you have to explain these two statements that he asked from you, right? In the form of Newton's laws, right? You're not only restricted to Newton's third law, you can explain it through all of the laws, right? And all of the stuff. If it said only, then you are restricted to only one stuff, but you're not restricted in this case to only one stuff, right? And you can't actually explain everything only using Newton's third law, okay? The all of the process. It requires you to explain from Newton's second law and first law, okay? So yeah, this is your final answer.